Hello to all of you. This is Dr. Dhaval Maheta, and today we are starting with a new series that is a time series analysis using views. Basically, it is known as econometrics. The literal meaning of econometrics is measurement in economics. The definition goes this way: the application of statistical and mathematical techniques to problems in finance. The areas in which econometrics can be used are: we want to test that are our financial markets having weak form of efficiency or not. We want to measure and forecast the volatility of the bond returns. We want to do the modeling of the long-term relationship between the two time series. We want to test the hypothesis that earnings or dividend announcements have got a significant effect on stock price returns or not. There are two types of data which econometricians have always to deal with. One, time series data. Second, cross-section data. Third, panel data. The data may be quantitative, that is exchange rate, stock price, number of shares, or it may be qualitative, like the day of the week. If we talk about cross-section data, any data which is taken at one snapshot or one time interval is a cross-section data. So here you can see the tax revenues of some states have been collected. The tax revenues for 2000 and 2001, and these are the states, only 1 year. If I talk about time series data, only one state and the past data of that state has been taken from 1990 to 2000. This is time series data. The previous one was cross-section data. In case of panel data, this is a combination of cross-section data with the time series data. So you can see here in columns, we are having states, and in rows, we are having year. This is a panel data. We always work on transform series, that is, we work on returns rather than raw prices. So how we calculate the returns? It is very simple. RT is equal to the present price minus the previous price upon the previous price. The same thing can also be calculated with the help of log returns. The RT is equal to ln, natural logarithm, present price upon the previous price into 100%. Now, this log returns has got some very nice properties. It can be interpreted as continuously compounded returns. Why to study econometrics? The basic reason is to provide empirical support to the theories. We make statements or hypotheses about the statements and hypotheses are very qualitative and we want to do the empirical testing for this. And for this purpose, we require econometric analysis. The second is to provide empirical support to the mathematical model. Many theories are expressed in the form of mathematical models, and again, we want to do the testing of these models. For this purpose also, we use econometric analysis. What is our framework? What are the steps which are involved in it? First of all, a theory should be there. Then a formulation of estimable theoretical model, collection of the data, model estimation. Is the model statistically adequate? Yes. Interpret the model, use it for analysis. If it is not statistically adequate, reformulate the model. Steps in econometric issues are: first step is we want to identify the research issue. On that basis, we will be selecting the variables. On that basis, we will check the data availability. Then we will specify the econometric model. The data collection is done. Then the model estimation is done. Hypothesis testing is done. And then this model will be used for forecasting and prediction. We'll be always dealing with the linear equation or linear regression in our analysis. The linearity can be interpreted in two ways: linearity in the variable and linearity in the parameter. So linear regression always means a regression that is linear in parameter. This I'll explain by using this chart. Variables are linear, yes and no. So you can see a plus b1 x1 plus b2 x2 plus, this is an error term. This is a linear variable. When I talk about non-linear, x1 square, x2 square. Now this is also linear. How come this is linear? I'll explain in next slide. Now what do I mean by non-linear parameter? So b1 square, b2 square, they are non-linear. These are non-linear relationships. And b1 square and x1 square, this is also non-linear. In our entire series, we'll be talking about this type of linear relationship. Now, how come this is a linear relationship? Let's try to understand. Y is equal to x square. If I apply log on both the sides, log y is equal to log x square. Those who are aware about the property of the natural logs, so log y is equal to 2 log x. Now this has become linear, and therefore, even if the variables are variables are quadratic, it is termed as linear relationship. Now the econometrics can be divided into theoretical and applied. Again, theoretical can be applied into classical and Bayesian. Applied can be classified into classical and Bayesian. We'll only be talking about classical applied econometrics. In applied econometrics, we use the tools of theoretical econometrics to study some specific fields of economics and business, such as production function, investment function, demand, and supply function. So, for more videos on econometrics, kindly subscribe to my channel and you can follow me on LinkedIn and Twitter.